So show us what you've done.
What have you done?
Okay, so my project is what effect does the type of energy have on how well a Stirling engine performs? The Stirling engine works off the displacement of air. So if you use an energy source such as heat, it'll heat the bottom plate and the air on the inside will rise, pushing the displacer up. And when the air cools, the displacer will settle.
And where did you come across the Stirling engine?
First things I did was I tried to create my own Stirling engine. It required such a high temperature differential, it did not work in my experiment.
And also, the piston is a tricky thing because it has to move, but it can't.
What I'm trying to do is I'm trying to improve the distance at which I can implement iris recognition with a cheap camera. I don't want to. I want to use the same camera that they use currently to recognize your iris. You see, they get up close to the camera and they scan your eye. It can't be done from a faraway distance because your iris is so tiny that you need a very powerful camera.
Right.
I mean, that's the obvious solution. You get a huge camera with a gigantic aperture, huge lens. It's very expensive. I implement super resolution techniques, which instead combine multiple low resolution frames into one high definition image. I use a video camera, so now I have multiple frames.
Right.
They're low resolution,
right,
but I have more information, so that I can realign them, shift them together, and then compress them into one.
Okay.
And now all that information is into one image, so now it's a better image. It reduces noise and aliasing. And so I use MATLAB to do here once I videotaped 6 subjects. It's a sharper image, the noise is reduced, and hopefully there's more sampling, meaning there's more real data in that image that I can then use, plug it into the iris recognition formula, which I got online for free. I'm at governor school, so we had to brainstorm for about a month on what kind of science project we wanted to study. And
you did a wonderful job, but if you do those things, now you did for eye, you can do that speech.
Yeah, there's lots of applications. Even
so
like
speech, then what you can do is the security, not only your eyes. We are from IEEE, Institute for Electric and Electronics Engineers, the world's largest organization of engineers and all this.
My project, my initial idea was to see if the oral cavity of your mouth would act as a corbellic dish and increase the directivity of signal to increase the maximum length at which the signal would travel. But my science board not let me do that due to possible health hazards.
Okay.
My next idea was I was going to use common objects you can have in your pockets or purse, and like a cell phone, your glasses, or credit cards or pens, and see how that would compel all the objects except for the glasses to the key fob. But I didn't do the glasses like that because the glasses were a lens. All my objects had little to no effect, and no significant effect really, except for the bifocals through the bottom lens. They were the only ones that actually had a positive effect. And actually, as an aside, I actually took an actual radio tuner from a modular radio and to compare it to the lens, and it actually had about the same effect. Do you have any questions?
Yes.
Right?
How many measurements did you make for each configuration? Like, for example, for here, for this one?
I did 4 separate tests.
4 separate tests, okay.
4 separate testing sessions.
Do you have that data?
Yes. It's over here. This is this 4 separate testing, 4 separate testing sessions. I only have 3 of the sheets. The first testing sheet was, well, I no longer have access to it.
You can do more work on it and definitively show, and if you wanted to really prove that hypothesis, you use lenses with different focal lengths.
So my project, I tested whether the amount of coils around the wire matters about the amount of voltage that's going to be created. So I tested 50 coils, 100 coils, and 200 coils. And then I also tested whether the speed of the magnet spinning around would affect the amount of voltage created. I also tested if the gauge of a wire would test the amount of voltage created. Coils, my hypothesis was that the more coils there was, the more volts would be created. So this shows that 8, 10, 22. So 200 has the most, so I kind of proved my hypothesis. For the spinning the magnet, my hypothesis was that a faster speed would create more voltage, but my testing proved it wrong, since the 350 had 8, but the 1300
You
RPM had
recall
only 2.
the law of induction, DL, if you have a coil of wire out, if the circle is constant, if the area is changing, then it's B times the area.
Right. In that case,
It should make an increasing voltage.
that's correct.
That's why I asked him about where is that field going to change the most? You have an N here and an S here.
Right.
It should be this way, not
Right.
this way.
Exactly. So what he's saying is that
To get the most change
like
in the
this,
magnetic,
it should have done like
it's not.
this.
It's what makes the voltage is a change in the magnetic field. Go to your project. Okay.
Because I kind of thought that you could compare this to like a wind turbine, how it's going
Yeah,
down around
you can.
really slow.
Sure.
And this is kind of like, I thought this is kind of like proving that
You
the slowness
can.
is creating more voltage because the slowness. Because in 35 per ohm, it should be going like this.
Draw onto an oscilloscope and watch the voltage change.
Right, exactly.
And then you can see it do something like this.
Why? Because you click.
Okay, we call it, my experiment, I call it motion lamps, but they put the ancient thermodynamics and convection currents into work. So as the cold air comes in to the lamps, warm air comes out, that makes a horizontal push that creates a circular motion on the lamps.
Right.
Well, essentially what we were testing was that the angle that would produce more motion into them, my hypothesis was that it would be the 45-degree angle that would create more motion into the lamps. These lamps, they come from Japan with the term of Mawai Doro, which is turning lantern. They used to have them for Buddhist ceremonies and to praise Buddha.
Are these incandescent lights or are they the mercury?
No, they're incandescent lights. Yeah. I just tried a 60-watt one because I wanted to keep control of my variables, because if I keep on testing my variables, then I would change my whole.
My question is it what, I'm giving you a line of research. Would it be better to just have a hole in the attic? Or is it better, does having a fan that's powered by the heat of the attic, is that better? See, I don't know. I don't know the answer.
The best answer that if I was just having actually a fan that goes in and that creates a lot of wind that comes in. What about if you just use this energy and just creates this huge container of energy, of thermal energy, being by the heat, and
But
just
you
create
see
it.
my question.
It's also that it will restore the energy that you had. So as a conservation of energy, we say that energy cannot be created, so it can only change its shape.
So we have to have an optimal number of fans. So there is what happens there, whatever the inside hit has a way to go out and then cold air, as you said.
Or this is essentially my first design of it. This is part of engineering to essentially have the air, the circumferences, but in this material, I used just regular glue on it and actually just tilt it because the weight distribution wasn't well distributed. It's a way to prove that even two pieces of paper on each one piece of paper wouldn't even move because it wasn't evenly distributed. The two pieces of paper evenly distributed would actually move it, but the one that only had one wouldn't even move. So that's how much precise you gotta be in your distribution of weight.
Do you have a journal, like a daily journal with your
chemistry?
This was actually my research.
You need to date it. When you do these, put dates on it, so we know how hard you work.
This is my research basically.